First type of division problem we're looking at has a decimal in the number we are dividing. So we have 68 and 6/10 divided by 14. So I'm going to very quickly make a fact table for myself. 14, 28, 42, I could still increase more, 56, and 70. So I can see that to try to knock down this 68, 56 is going to be my closest factor of 14 that I'm going to use. So I'm doing 14 times 4 to get 56, and I'll increase it to 40 to make it 560. I do my subtraction. We are ignoring our decimal for now. We're going to pretend it's not there, and we're really just doing 686 minus 56. So, as I do my subtraction, I have 126 left over. So I'm going to look at my fact table, and I can see that the 14 is already too high for the hundreds and tens. So I'm just going to increase one more very easily, and I'll use 84. So that would be 14 times 6. I can do my subtraction. I'm left with 42, and I can see that 14 goes into 42 exactly 3 times, and I'm left with 0. So my answer to this problem, when I add it up, is going to be 40 plus 6 plus 3, which would be 49. Now, looking at our problem, I'm going to use a quick estimate. 14 times 49 is going to be way over my original problem of 68.6 divided by 14. If I use my fact table, I can see that 14 times 3 is 42, 14 times 4 is 56. So it would make sense that 14 times 4.9 is going to be slightly more than 56, but you can see that it's not the same as 14 times 5, which is 70. So my answer is 4.9. Now, the only reason that this actually worked out well is because we have a remainder of 0. If we're going to get a remainder of 0, whether the decimal is in our divisor or the number we are dividing, you will be able to use this estimate logic to place your decimal. If it was in both numbers, we could still use the same estimate logic to find our answer. What we're going to look at next is when there is a remainder, how you're finding the exact decimal instead of just writing it as a fraction. As you can see, we have 869 divided by 16. Real quick, going to make my fact table. This always just helps me solve the problem a little bit faster. And I can see that the last one I just wrote is going to work perfect to start my problem. So I'm going to have 16 times 5 to get me 80, and times 50 to get me 800. Do my subtraction, and I'm left with 69. And I can see this is working out great for partial quotients because I can do 16 times 4 for 64, and that leaves me with 5. So in this case, I'm down to my remainder. So I know that I have 54 and 5/16, and I could write that as my answer. However, we want to explore how we can use this to find the decimal of 5/16. Now, one way would be to know how to convert 5/16 to a decimal, but I can show you a strategy that you can use to get an exact decimal answer. Once you are down to your remainder, we need to divide this problem by place values. So I need to make it very clear that I am done with my whole numbers. So I'm going to draw on this very dark line to remind me that 54 is my whole number. And I'm even going to write that there and circle it. Okay, that's my total for my whole numbers. Now what I can do is add a place value to the number 50, or to 5 to make it 50, and continue with my normal partial products process. Partial quotients, I apologize. I can see that 3 is going to work best here. Minus 48, and I'm left with 2. Now again, I have a remainder. So that 3 represents our next place value, which would be the tenths. And I'm going to repeat the process once again. Add a 0, and I'm going to now use my fact table, and I can see that 1 is going to be my best option. And again, I have a remainder. So I need to divide by place values again. Separate that. The 1 is in the hundredths place. I'm going to add a 0 to my 4. I'm going to extend this line down a little bit to give me more space. Use my fact table, and I can see that 16 times 2 will be my best option. 32. Which leaves me with 8, which is another remainder because it's less than 16. And now as I add this 0, I can see that I'm not going to have a remainder on this one because I know that 16 times 5 is 80. And once I have 0 remainder, I am done. So I can see my place values building out from my whole number. So my answer is 54. And I know that that was the end of whole numbers, so I need a decimal point in there. My next place value is the 3. My next place value is the 1. And the next is the 2. And the last is the 5. So, you could grab a calculator right now, type this in, and check to see that it works for our answer. Now I just want to go back for a second and